Monolithic IC technology, also known as planar circuit technology. Monolithic means formed on a single silicon chip. In this technology, we have these various steps that will be followed. Crystal growth of a substrate, formation of epitaxial layer, silicon dioxide layer growth, photo etching, diffusion, evaporation of aluminum. Monolithic IC technology. Step 1 is the epitaxial process, is one in which a thin layer of high resistivity silicon is grown on a low resistivity substrate. An N-type epitaxial layer 200 micrometer thick is grown on a P-type substrate. The PN junction thus created across the entire slice. Second step, an oxide layer SiO2 0.5 micrometer thick is grown on top of epitaxial layer after polishing and cleaning. This is done by exposing the epitaxial layer to an oxygen atmosphere and heating at about 1000 degrees centigrade. SiO2 has the property of preventing the diffusion of impurities through it. Step 3, the entire top surface of the slice is now covered with a film of photoresistive emulsion such as Kodak photoresist. The first photographic mask containing the electrical isolation pattern is placed on the slice. Upon exposure to ultraviolet light, the portion of photoresist underneath the transparent areas become polymerized. The unexposed areas outlining the isolation pattern are etched in a chemical. The portion of the oxide layer not protected by the photoresist is removed by dipping the slice into an etching solution. With another solution, the remainder of photoresist is then dissolved. So the first diagram shows after placing the mask containing the solution pattern on top, the photoresist is exposed to ultraviolet light. So there will be exposure of ultraviolet light. So it always okay. But these regions, this is transparent region. This is a transparent region. Portions of the photoresist exposed to the light polymerize. The rest can be dissolved. So the oxide not protected by the emulsion is etched off. So these are all the places it has been etched off. Here also. The slice is ready for the first diffusion. P-type impurities are diffused through the windows. The diffused regions connect up with the underlying P region and form isolation pockets in the epitaxial layer. So this diffusion takes place at approximately 1200 degrees centigrade to a gas containing P-type impurities. After the isolation diffusion, the oxide layer is reformed and the slice with the photoresist form for the second time. So this oxide and photoresist are again relaid. Again mask will be placed on that, and then that is it is exposure to ultraviolet light and then removal of the unwanted portions. So it is going to be the process gets repeated in order to build various layers. So now through that exposed areas, a new layer has been formed. So you can see in the N, P layer has been embedded. So this through that area diffusion takes place, and in the N region another P region has been formed. So this is going to be a repetitive process, and you can see here diffusion, here diffusion, here diffusion going to take place. So this forms another N plus region here. So this is going to be a repetitive process, that is several layers or several time this will be done. See, once this has been completed, and now connected materials to be made. Okay. For example, a thin film of metal such as aluminium is evaporated over this slice. So now the entire slice is covered with a thin metallic film. This shaded, this is thin metallic film. So this is to enable connection with the various layers, or with various say for example emitter base collector of a transistor. On top of the metal layer, the photoresist is spread, and it is exposed to a mask which contains the interconnection patterns. After removal of the unexposed portion, the photoresist, the regions of the metallic layer not needed for interconnection or etched off. So the final result will be something like this. So here unwanted portions removed, right, and only those portions where we want to make connection. For example, so this is a collector, here they will take lead, this is emitter lead will be taken. Similarly base lead will be taken out. Following are the main features of this type of technology. The junctions are protected by the oxide layer during and after formation, and are therefore never exposed to air and cannot be contaminated. This results in a low leakage current and high reliability. Photographic techniques are used to determine the geometries of all devices and the isolation, making possible very small dimensions and thereby the simultaneous fabrication of a large number of devices and circuits. Thank you very much.